In this example, we are going to develop a value model for the Vista system. So looking at our model right here, this is Physical Architecture 2. We've also generated Physical Architecture 1, which is fairly similar as well, just a different layout. And we're going to develop value scores for each of these so that we can do a comparative analysis. So first thing we're going to do is create a new package called value model, which is right here. And in that package, we're going to create a BDD. And I'm going to call this just value model parameters. In here, I'm going to create a block. We're going to call it value model parameters. And in this example, we are looking at six separate value measures. And they're all tied back to our requirements. So if I go back to my requirements, I can look at my system requirements for weight. That's one of my value measures, less than 2 kilograms. I also have a performance requirement tied to a value measure for memory storage, which is right here. I also have one for battery life, one for voice recognition time, data processing accuracy, and finally latency. So I have 6 value measures tied to each of these. So we're going to evaluate each of those each of those physical architectures, both of those physical architectures based off each of these. So for my value measures, I'm going to now set the parameters I need. The value functions are going to be based off these requirements, where the threshold value is set by these requirements. So 2 kilograms for weight is a threshold. And of course, we have an objective value. We're trying to get it as light as possible. So like 0.1 kilograms would be an objective value. And what we can do then is based off the values, we can develop a linear value function tied to the threshold and objective values to evaluate the value score for that parameter for each of our designs. So I'm going to create a series of value model parameters in this block. So value property, I'm going to call this first one T1, and it's going to be type real. I'm going to create another one. That's my threshold value for my first value measure, O1, make that type real. And then my swing weight value, how much we're weighing that. That's also going to be type real. Just to save some time, what I can do now is I can go into my containment tree and I can copy and paste those 5 times. So I highlight those 3, hit Control C, paste, 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 paste. As you can see, I now have the values I now have the value model parameters all defined. Now I need to give them values. So if T1 is, T1 is going to be my latency. I actually have this backwards, ordered it backwards. Let me just rearrange these. And so my threshold value for latency is going to be 2 seconds. So I can go ahead and set that. And my objective value, I want to be as fast as possible. So let's do 0.1 seconds because that's fast as that's realistic. And I'm going to set that to have a swing weight value of 20. Next up is my second value. I'm going to set this to be 0.95, 0.99, and 80. T3 is going to be 1, 0.2, 30, Battery duration, so T4 is going to be 24. Objective, let's set to 72. And a swing weight of 60. T5 we're going to set to be, we're going to set that to be 100. Objective 300. This is the onboard storage. And we're going to set that to be, have a swing weight of 70. And for T6, I'm going to set that to be 2.0, 0.5, and 90. Now it's useful to show the traceability for each of these threshold requirements. So I'm going to do a trace arrow from T1 to latency, T2 to data processing accuracy, T3 to voice recognition time, T4 to battery life, T5 to onboard storage, and T6 to my system weight. Quick diagram layout, and it shows more or less that traceability, and as well as having all those parameters defined. The next thing I'm going to do is I'm going to create a block for a generic Vista system that's going to have certain parameters, and we're going to call them raw 1 through raw 6. It's also going to have a final value score. So these are the raw parameters. So raw 1 will be the latency time for any of our Vista systems. This is going to be an input port. So we're going to input these values in, so we don't have to define raw values in here. And I can, after I define one, I can just copy and paste it 5 times. And then I'm also going to add a score. And that's my final value score for an alternative. I'm going to make the value mall parameters a part of my Vista system. And I'm going to hit save. And now that I have this defined, I can start defining the parametric diagram that underlies all of this. So we're going to create a parametric diagram of our Vista system where we get a score based off these 6 raw values and these value mall parameters. So I'm going to create diagram, parametric diagram, and I'm going to expand out my value mall parameters and go and select all of those. I'm going to go ahead and hit OK. And something that looks like this. Let's just organize this a little bit. I'm going to move score over to the right-hand side, put that guy right there. And yeah, let's start building. We have all of our threshold and objective values. We have our swing weights. We have our raw values. So first thing we're going to do is build out value functions. So value function in this case is much simpler, is pretty simple. We're just going to use a linear interpolation between the threshold and objective values, capping it at 0 and 100. So I'm going to click on constraint property and create a constraint block called value function. And I'm going to add in 4 parameters. First one's going to be the raw. That's going to be your input, your objective value, your threshold value, and your score. So basically I'm going to use that raw value and interpolate it between my objective and threshold values and assign a score between 0 and 100. So the linear interpolation is pretty straightforward. It's just score equals 100 times raw minus t divided by O minus t. So pretty straightforward. However, if we want to cap it at 0 and 100 so you can't get negative values and you can't get excessively high net values, we can do this is equal to minimum 100 So if it's greater than 100, it just defaults to 100. And then max 0, where if it's less than 0, it'll default to 0. All right, so the next thing I want to do is I want to copy this 5 times. So I'm going to come over here into my containment tree, do copy and paste. So copy and paste that 5 times. I'm just going to drag these onto my panel now. You'll notice that they don't contain their parameters, so let's have display constraint parameters, and they're now there. All right. So next thing I'm going to do is I'm going to rename this first one to be value function 6, just so that, because it started naming at 1, then 2, then 3, then 4, then 5, so I needed a value function 6. And let's just get these organized. All right. So what I can do next is I can start connecting my values. So raw1 binds to value function 1, raw2, value function 2, raw3, value function 3, raw4, value function 4, raw5, value function 5, raw6, value function 6. O1, value function 1, O2, value function 2, O3, value function 3, O4, value function 4, O5, value function 5, O6, value function 6, T1, getting a little messy. All right. So we have everything connected here. I'm going to do a quick diagram layout so it looks a little bit nicer. Now, next thing we have to do is we have to figure out what our, we have to take care of our swing weights. So I'm going to create a new constraint parameter, constraint property for my swing weights. I'm just going to call this swing weight. In it, I'm going to have take my 6 swing weights and convert them to 6 global weights. So that's going to, I'm going to create 2 parameters initially, swing weight 1, global weight 1. And now I can go over to the containment tree and copy and paste that five times. And then to get them to appear here, I just need to go to display constraint parameter. Display constraint parameter. All right, so I have all my constraint parameters now displayed on here. The next thing I'm going to do is I'm going to do the math. It's going to be a series of 6 equations. So I'm going to go and define that for the first one. So global weight 1 is equal to swing weight 1 divided by the sum of swing weight 1 plus swing weight 2 plus swing weight 3 plus swing weight 4 plus swing weight 5 plus swing weight 6. All right. If I want to do all 6 equations, probably the easiest way is to open my the specification for here, go to my constraints, and you can see that I have this defined. I'm going to create 5 more. Oh, sorry, back. I'm going to clone 5 more. So sorry, I just hit Control Z to undo that last step. I'm going to clone this and create. Now I have 6 of these. I'm just going to edit each one of these. So it's global weight 2 equals swing weight 2 divided by the sum of those. Global weight 3 equals swing weight 3 divided by the sum of those. Global weight 4 equals swing weight 4 divided by the sum of those. Global weight 5, swing weight 5 global weight 6 equals swing weight 6. So you can see it's all in the containment tree. Let's see what display. Okay. Yeah, it just need to be updated. Display all my constraint parameters. All right. So next thing I can do is I can start linking things together. So my swing weights all got a little jumbled, but let's go and connect those in. Swing weight 1, swing weight 2, swing weight 3, swing weight 4, swing weight 5, and swing weight 6. So now that I have the global weights and I have the output scores for each of my value functions, all I have to do is do a sum product type thing to get my final score. So I'm going to create another constraint property. I'm going to just call it sum product. I'm going to create an initial constraint parameter. Just call it score 1. And second one, call it global weight 1. Then just like before, I'm going to come over here and copy and paste that 5 times, so that I now have 6 scores and 6 global weights. I'm also going to add in one more as my final score. That's going to be the output of my value model. And now the equation is pretty straightforward. It's just score equals global weight 1 times score 1 plus global weight 2 times score 2 plus global weight 3 times score 3 plus global weight 4 times score 4 plus global weight 5 times score 5 plus global weight 6 times score 6. All right. And you can imagine there's some easier some shortcuts you could take with multiplicity and things like that. But for the sake of this example, we're keeping it simple and just doing it like that. Now all you have to do is do some linkages. So global weight 1 goes to here. Global weight 2 goes to here. Global weight 3 goes to here. Global weight 4. Global weight 5. Global weight 6. So score 6. This is score 1. Score 2. Score 3. Score 4. And score 5. Now looking at here, the only thing that's not set to anything is my final score, which is right here. So I'll link that to that. Going to hit Control Save. Now I'm going to do a quick diagram layout and just talk you through again what all we just did. So we have our 6 raw values. So these are like your latency times, a system weight, those type of values. And we feed them into value functions. The value functions do a linear interpolation between the threshold and objective value, capping it at 0 and 100, and gives you a score between 0 and 100 that is outputted. We also have a swing weight, which is the score between 0 and 100 that evaluates how much we're weighting each of our value measures. So we have a new box over here for a new constraint over here for swing weights, and we calculate out the global weights. We convert that swing weight value, which is between 0 and 100, to a group of global weights that sum to 1. After that, we just do a sum product where we output the scores from each of our value functions, multiply it by the associated global weight, and that gives us and sum them together to get a final score. with our value model built, we can now go into our physical architectures and evaluate them. So I'm going to go back to physical architecture 1, and I'm going to create a new value measure, create a new value property, physical architecture 1. I'm going to call that score. And I'm going to set that to be a real number. I'm going to also define a few different parameters. I'm going to put in values for each of these. So my response time, I'm going to set it to have a default value of 1.0 seconds. My accuracy, I'm going to set it to be 0.96, so 96% accurate. My processing time, I'm going to set it to have a default value of 0.3. Battery life, I'm going to set it to be 72. And for memory storage, I'm going to set this to be 128. Right. You saw that there's two different ways I set those values. You can either click on the side and just enter it with an equal sign following the type, or you can go into the specification box and just put it in there. All right, so the next thing I need to do is I need to create a parametric diagram to calculate out my score. So for physical architecture 1, I'm now going to create diagram, parametric diagram. And I'm going to select my 5 value measures on here. So I'm going to select my subsystems, expand them. And let's see, we want to have the ATAC, the memory storage. We want to have the conformal battery and battery life. We want to have the QA software, accuracy and response time. We want to have the voice software, and the processing time. So that should give me my 6 value measures. Let's see. 1, 2, 3, 4, 5, 6. And then my final score. So I should be good. All right. So I'm just going to move a few things around. And so I have my all my value measures right here, my score over here. Next thing I'm going to do is I'm going to drag over my Vista system from my value model. And I'm going to have it display the value properties in it. All right, so what I can do now is I can link them all up. So my mass is related to my 6 value measures, so raw 6. My memory storage is going to be raw 5. My battery life is going to be raw 4. My accuracy is going to be raw 2. My response time is going to be raw 1, because that's my latency. And my processing time for voice recognition is going to go to raw 3. And then my score is going to go to score. Quick diagram layout to make this look decent. And we have everything lined up now. I'm going to go ahead and hit save. I'm going to go back to my physical architecture. And I'm going to go ahead and run it. Let's see what happens. I ran it, and you can see at the bottom right here that physical architecture 1 has a score of 61.8789. If I expand these, you can see some of the underlying, you can see the input values right over here, my raw values. You can expand out, see like all your global weights, all your everything that's all captured in that simulation window. So what I'm going to do next is I'm going to repeat this process for physical architecture 2. And it's going to be pretty much the exact same process all over again. So for physical architecture 2, I need to add a value property, just call it score, real. My response time. So again, for physical architecture 2, we're using a faster system, so we can cut down our response time. It's probably going to be like 0.7 seconds. We're not forced to use the ATAC software, so that's going to be probably a little more accurate. Let's do 0.98. Processing time, let's do it as being 0.2. Battery life is going to be a little bit lower. So let's set that to be 24 hours. Memory storage is going to be much higher because, again, we're not constrained to the ATAC device. It'll be 300 gigs. And our system weight is going to be 1 kilogram. It's going to add considerable weight. I'm going to create my parametric diagram again. I'm going to select all the things I need. Let's see. Helmet system. Lithium ion. Battery life, so that's 1. Raspberry Pi. Memory storage, that's 2. Software subsystem. Let's see. QA software. Accuracy response time 3, 4, 5. Score. So I have my battery life, memory storage, mass, accuracy, response time, processing time. Then my final score. So I think I'm good. I'm going to hit OK. That looks good. Let's put score over on the right hand side. Let's go ahead and drag our Vista system back over here. Let's have it display all. Oh, don't want to display all. Control Z to undo that. Display value properties. Start doing the linking. So mass is raw 6. Accuracy is raw 2. Response time is raw 1. Voice processing time is raw 3. And score. Quick diagram layout. Go back. Run a simulation. And you can see that this guy has a score of 66.7669, so a higher score than Physical Architecture 1. You could imagine that all the things that you could do now, like suppose you wanted to do a sensitivity analysis, you could change around your swing weight values so that they're a distribution. You can change around your input parameters so that they're distributions, and then just run a Monte Carlo simulation, do a full-on sensitivity analysis, much better than you could do in Excel, and allows you to actually look at how it varies across a certain range. That's a little bit out of scope for what we're doing in this class, but here you can see us building a full-on value model using MSOSA.